All right, welcome. We're going to get back into working on this binary file deep dive stuff, working on generating a PE file with higher level structures for the API. The, um, the screen I've got up here is your regular reminder that all the work I am doing on this project, plus a bunch of other projects, my YouTube videos and stuff, it's all funded by supporters and members who come over here to mrforth.com/membership. So if you have a little bit of spare cash and you'd like to see projects like what I'm working on continue to make progress and see where they go, then consider becoming a supporter. It's much appreciated. Now, for this project, I just asked this question, so I'm going to delete that. I think we did this. So we're we made a lot of progress last time on these loose section relocations, but I also generated tons of to-dos. So I want to think now. About where to start making progress today. I think section indexes would make sense. So here we have a section indexing problem, which is that our label has a a generator section, and we're trying to find the layout section that corresponds with it. So I think what we want to do is we want to have an API that would allow us to key the sections in a way that is more like an array, more like a structure of arrays kind of thing. Like if the key for the gen section wasn't a pointer to the gen section, but instead it was a index into an array, then I could get to the gen section or the layout section from that index, right? Biggest problem I can think of is, well, let's take a look at what the API would look like in a usage code way this time. So if I were to zero out this and instead build something like this, this could look like this, for instance. I'm just sort of sketching out what I think a more sophisticated version of this API might look like. And section text, relocation offset, bit offset of 0. Byte offset, bit offset. Number of bits. The target. Flags. The bias. And of course we also need the value shift. Off, bit off, num bits, flags. Okay. So the point here is that I was able to generate the sections as IDs, and then the API is set up to let me set information on the sections bit by bit here. Then I can do, like here we've got Yeah, this API here is... Okay, so an API like that has the following advantages. One, because we're going to do sections as IDs now, when we go to make something like a label, we're storing an ID instead of a pointer, and that ID can then be the key to getting to like any kind of information about that section, rather than just the information that is directly available from the pointer, and then we'll be able to do section pointers better. What we won't necessarily have is these IDs. I don't know if they're going to match what we want the final section indexes to be, because there's still this sort that happens in the middle of the layout. So after the sort, we would need to assign final section like numbers, the section numbers that correspond to the section numbers in the file, and we would use that section number or that section index here, not the section indexes from the IDs we use in the API. It's a little confusing, but it's what we would have to do. So we would have to do if we're going to allow the sections to be reordered, which we don't have to do. But we have some possibility that we want to be able to sort these. If we have section constraints, which is still part of the idea, those section constraints might require the order of things to be different than how they're declared, and then we'll need the sort. Ooh, I'm low on water. I might take an early break just to fill up my water, because I'd like to have more. But I'm gonna keep going for a sec at least. Let's see. That should have busted everything. Yeah. So let's imagine the version of this where that is what we do. So the big changes are going to be, we're not going to use gen section pointers anymore. We'll make a 32-bit pgen gen ID type, and that is what we're going to use for keying things. Layout section won't contain this anymore when we're done. Sections won't look like this. Okay, yes. Everything's going to change. Everything is going to change when we make this transition. Even starting with the fact that we are now dealing with something like this. Okay. So up here, okay, the file begin doesn't need to be this high up. The file doesn't actually get used until down here. Okay, so then we get things like I don't know if I want to keep calling this context forever, but that's what I'm going to leave it at for now. So I'm actually going to rewrite lose construction helper a little bit here. I think, well, no, I don't need to rewrite it. It's just that I think this can be removed. Okay, and then all of that's out, and in its place, we're building up this heavier duty API. So let's see, all of this is out, and this heavy duty API is taking its place. Allocate an arena. Put a context on it. So what we're doing here is a trick where we are creating a large sort of system context, and we're giving it its own arena. So all the stuff we do on this context will play with that arena. And when we're done with the context, we'll do this. Now, if you're seeing this, and you're thinking, hey, that looks like a malloc and free prep pattern. You have to begin and then release this thing. Yeah, that's what it is. If it turns out later that we don't like that, and that causes problems, like if we want to do lots of little ones of these, then yeah, this would suck. I'm not expecting that kind of use case, and it's easier to set this up like this. But if we had to, we could go through and set up to always pass the arenas in. Then we wouldn't need a begin, and we would still need a begin to initialize the context potentially. But we would then say anywhere where we're passing a gen, you also pass the arena in. And now the arena isn't owned by the context. The arena, the user is responsible for making sure that the same arena is used throughout the system, which makes it a little more tedious for them to use, but it gives them the flexibility to say, like, okay, this arena is going to contain these 5 contexts, or, you know, this arena here is being used for this UI element and this PE generator context or whatever. I don't think that that's going to be a use case anytime soon. In fact, it might not ever be. I think constructing one of these is a little bit of a heavyweight task, and it doesn't bother me to allocate an arena at the beginning of a heavyweight task. Okay. All right. Now, a part of the problem here is going to be, how are we going to map these IDs to internal section information, right? Everything we've got here is like sort of what we want, but a little bit off. We're going to want like this, sure. We want the name, data, vsize flags, and the pointers all attached here. But we might not want to keep chaining it like this. One possibility is that we start off with an array. Right, we might go like this and have a cap early on, right? So we could say like, okay, we can handle up to 100 sections. Weird thing about that is like, do we want it to be allowed to run out? If we're going to need to have a growth strategy, how is that going to work? It's not usually what I go for on an arena. But I still want my IDs to be able to act as keys. We could go the opposite direction and say, hey, it's going to be easy on the memory system. We're going to have these like gen section, this gen section map thing, and the map will look like this, and then one of these would be like next So now what you'd have to do is you get an ID and you'd scan across the map one by one to find the matching section, right? So it really comes down to how many of these we expect to have, if that works. And once we have them all, once we go to do layout, we can bake this. Zampy, yeah, I remember. I'm glad you got forecoder working. That's great. Yeah, Linux causes problems. That's for sure. Hey, Young Lane, welcome. Sometimes the way I handle something like this is I would treat it like an entity system. And so you'd have this like dedicated block of memory reserved. It'd basically be an arena reserved just for allocating the things you need to make indexing into. And you'd make sure it was contiguous and just set it up with a reserve of like, hey, make sure we can get to 1 million entities or something. And then commit in small batches, right? You'd have an arena tuned up just for creating the parallel array that goes with these section IDs. Here I've already got one arena that's going to need to be, like, I already know I'm going to need more than just an entity type. I'm going to need other stuff. So I think I'm tempted to do something like this. We're going to say, whenever we create a new section, we do this to get the new ID, right? We're also going to go make a new section. So we start using the gen arena. And then what we do is we pick a stripe by going, take the ID modulo the section slot. We SLLQ push. We SLL stack push. Is that what we want? Section slots, stripe index, a new section. And I think what we'll do is we will just include an ID right inside there. If we wanted to, we could redo the layout on this. Like, we could definitely squish some of these together if we did it like this. It's fine. I'll just do that just for sake, just for the fun of it. Store the ID on this and return it. And so now I'm gonna want these like okay. So what that basically means is for 32 sections, we will have constant time access, which is going to be more than enough for a lot of the files I've looked at already. After that, the most recently created sections will be accessed faster. And if this does hit a point where it's like, hey, we've got 1,000 sections and this is too slow, then we replace it. We do a more sophisticated data structure again. But now I can start writing things like this. good. Okay. We're grabbing the section that we're going to need. We're allocating a pointer. We're pushing onto our section. The putter count. And we're leaving all of the rest of it uninitialized on the putter so that whoever's calling can fill that in without having to pass it all down, because that's a little bit too much passing when what we're trying to do is just get all of this initialized. So we got 8, 16, 2, 3, 4, 5. So it's 32 bytes right now for each one of these, which is fine. We can worry about that more later if it really matters, but I think it's fine. Okay. Now, before we were generating this struct called a layout. And the idea was we were building up the list of things, and then we were running it through a layout function. I think we'll still think about it that way. Maybe. It's just going to be that now we only pass in the context. And that spits out a layout for the current state of the context. So the downside of doing it this way is it's going to go right on this guy's arena. I'm going to take my break. I'm going to take my quick break and fill up my water. And I'll come back and think about this step with a fresh head. So I'll be back in about 5 minutes. Okay. So the layouts pass is for taking the loosely arranged data and baking it for final use. Something like that, maybe? And then I think what I'll do is I will allow you to send that to any arena you want. And we'll have the adjust pointers go in it like that. You come up. So you use this API to build up your context, and then you do a layout on it when you're ready, and you put that into any arena you want. Okay. Okay, so this gets replaced with this. Probably going to be very similar in many ways, but can be different too. What if we... yeah, something about the layout. I'm not quite sure how I want it to look yet. Maybe something like this, but I'm not sure. We're going to figure this out as we go. So first things first, we have this loosely structured section system. I kind of want to turn that now into, all right, we need a scratch. We want to put together a data structure here that'll let us index our sections fast. So there'll be an array of pointers to these things. And then what we'll do is for each slot in the section slots, for each section node, in each slot, and what we do is we go to the gensec ID -1, and we store that, right? So for each of these in the whole table, we just end up putting a pointer to that node into the correct spot in this array. So we end up with a fast section indexing. Okay, we've got an array of those pointers, and then we need to calculate the header size. Then we lay out the virtual space. Right now we don't have any virtual layout constraints, so this is just trivial, but this is where we would put in those constraints. So I'm going to leave a to-do there to remind me that that's happening. So that sorts our lay section putters. Here we can do the section indexes because we've got the sort done. So we can do lay section putters I section index equals I. There we go. We can set the file offsets. Gen sections. So the ID we can get by going lay section minus lay sections plus 1, right? And then the gen section we can get by going gen sec equals gen sections ID minus 1. So this could just be like this. There's our fast indexing coming in clutch. Because we want to go gen section data size file align right there. And then finally we fill the final layout. Okay, we need to use this again. Up here. And right here. Right. So I'm thinking more and more that I kind of wish the layout section just contained everything it needed on its own. You know, like it could be like this. And then what we would do is when we first make our layout sections, we just fill them up with all the stuff we already know about them from the gen sections, and we work on them from this position of forward. How would that feel? So we already know about the V size. We already know about the F size. That's going to be the data size. I'll line up how to file align. Actually, let's just say it's going to be this. We know about the name size. And then we won't need any gen sections anymore, because the layout sections just have everything we need. We're going to deal with that separately. Apply pointer adjustments. Now what happens is for each section, we're still going to use the gen sections one more time. feel like I should not modify the data in place. So I'm going to push a copy of the data on each of these when I make them. And then what happens is we want to extract target location. So target is the gen putter target label. That hasn't changed, right? That gives us the target section ID. And then it looks like we're going to want the target layout section, which is just going to be the lay sections plus this ID minus 1, right? That was kind of the whole point here, was to get to the point where we could eliminate that scan and use the IDs themselves for this kind of thing to access stuff faster and to also make the API a little more sophisticated in terms of its flexibility. So we've achieved both of those goals now, but we have to finish getting feature parity to the original code. Here's how we calculate the value. That hasn't changed. Here's how we set the relocation bits. This changes just a little bit. Let's grab the data off of the lay section up here. And now this is just data and data. So I don't want to divide by 8 and round down, I realize. I want to divide by 8 and round up. We kind of want to assume certain things about the gen putter. Like we want the bit off to be less than 8. We want the relock off plus target size to be less than or equal to F size. Cool. Okay, so that looks like it worked. So I can kill the old stuff. Looking good. So we still haven't solved this problem, but that's okay. We got that. That's all working. All right, so let's try going up here to text. I'm saying like, okay, we want to drop in different number. Yeah, that works. What if we wanted to do something like, say, awesome. Okay. I think that this is pretty good. Let's check that much in. Okay. So we could track down some ideas for the section layout constraint stuff. I guess the main thing I want to do at this point is I want to take a step back and figure out where, you know, I've completed some doable stuff. I kind of want to now do some, like, shoot for something hard again. And this would be hard in the sense that it would be complex and interesting to solve, but not necessarily hard in the sense that it would help me to further understand the PE format right now. And I want to focus on that kind of thing more. So I think I want to hold off on this because this is more just an algorithm problem, and I want to do more format stuff. This would be an API design problem, and I want to do more format stuff. So I'm thinking... I'd like to work on having a function call happen within this code right now. I think that would be an interesting challenge, because if I had a function call in there and I had to actually, like, the function call actually needed to work properly for the results to come out the way they're supposed to, that would force me to think a little bit about relocations. Maybe I would have to start generating relocations. Another thing I could do... Okay, this we can actually improve, right? So if the target lay section is known, then we just need its section index. So that's cool. This part right here. I want to put those into the layout. I don't exactly know the appropriate way to count these to make to match what PE expects, but I've also found that this didn't appear to be super sensitive. Like, if I get this, if I do it slightly differently, it doesn't seem to break the executable. So this might just be kind of a thing you do for the sake of a thing you do for the sake of any tool that happens to want to get an idea of these things, but maybe it doesn't have to be exactly rigorous. Not sure. Still, let's give it a shot. So when we go here, yeah, I'm just not sure what these are supposed to be. Is it like this? That still works. So that's cool. All right, how would we automate the entry point VOF? I think we would need to have some label that tells us where the entry point is that is provided by the user. I mean, okay, so here's the thing. The flow of this so far is you use a context here to loosely construct your object file or your executable file. Then you generate a layout, and then you finally build a file. I haven't pulled that out into a function, but I totally could. I think it would make a lot of sense to start thinking about it that way. That's good, because now Scratch can come out here like it should. That's great, that just works. Apparently we succeeded at not having any other globals in there, which is cool. Okay, now the point is, the entry point VOF could just be built into the layout, but in order for that to be done, it would need to be told to the layout function where the entry point is, which makes me think it would need to be told to the context in the first place. So we're looking for an API like this. Right, we would do something like this. And then the layout will contain an entry point VOF. If the context contains an entry point label, then what we want to do is we want to go grab the layout section from the entry point label section -1. offset that we grab off of that label. Entry point voff equals okay. Grab the entry point voff from the layout. Now this should break because now it won't know where to start. And that's good. Now what we have to do is go entry point voff up here when we're creating labels. Cool. All right. All right. So that's a little bit interesting. So now I'm out again. Let's see. I could still probably afford to do 10 or 20 minutes on this stuff if I can think of something to do. I think that was this X that I just finished. Let's actually check that in. Alright, so I think trying to get 2 functions is the right next step, and maybe we can take that on. That might take us a little past the 2-hour mark, which is generally when I like to be done with a stretch of coding like this, but if it takes us a little past, that's not the end of the world. We'll make it work. We're going to need a Godbolt instance here. Okay, now I gotta do is figure out how I'm gonna copy I guess we'll do a split screen. Full screen, closed panel, like this. And let's get to it. So this is going to be OX55 push RBP 48 OX89 OXE5 MOV RBP RSP OX48 OX83 OXEC OX10. So I'm thinking we might want a little Godbolt, like a little local Godbolt helper that can work with automating a lot of this more. You know? Not to build into my software, but like as a tool for accelerating the iteration here. Anyway, so we did MOV RBP RSP, and we are doing sub RSP OX1. I wonder what leave does. I don't think I've seen that before. Let's go read that one. Oops, I skipped one. I skipped MOV EAX DWORD putter RBP minus OX4. This is such debug code. We should go trim it up a bit. 8B OX45 OXFC. Looking for the leave instruction. Leaves the stack frame set up by an earlier enter instruction. Copies the frame pointer in the EBP register into the stack pointer register, which releases the stack space allocated. Build frame pointer, the frame ESP equals EBP, stack address RSP equals RBP. Stack. Okay, I see. We're just setting the stack pointer. It's just basically MOV EBP into ESP or RBP into RSP. And then it pops one thing for the Frame pointer as well. Okay, got it. Well, interesting. So we're pushing the RBP here. Popping it here. As well as returning the RBP into the RSP. Okay. All right. All right. Main, here's square. Push RBP. OX48, OX89, OXE5. MOV, RBP, RSP. OX89, OX7D, OXFC. Okay. Now, the question is, how does the call instruction need to be working? That's the big thing at this point. We have here rip relative addressing. Here, let's get these things sorted out. Cool. Full screen, V-split. So right here, we have the rip relative addressing. So the relock off is no longer at 2, it's at 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it starts at 10. That needs to point to var 1. It's going to be a 7. Now this right here, I don't know how to do this part yet. Call instruction. E8. Relative displacement relative to next instruction. 32-bit displacement sign extended to 64 bits in 64-bit mode. Okay. So E8 CD. Calls are complicated. What is the encoding for REL32 is 32-bit displacement. Okay. So this must be the displacement. 10, 11, 12, 13, 14, 15, 16, 17. We want it to point at square. So relative. This time, no need for bias, right? I still think we need a bias of 4 because it's going to still be based on whatever's past this. And so here we go. 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Whoa, that worked. All right, cool. Cool. Okay. Let's drop 6 off of this. That shouldn't change anything else. Really cool. Wishing I knew how to encode MOV EAX EDI by hand. I don't. Okay, cool. I think that that's a good spot to stop for today. We are able to do more sophisticated stuff with layouts and the placement of pointers and stuff. And the API has been improved to the point where I can sort of loosely start adding in new stuff successfully. I've got a handle on how to do this. Maybe, so one thing to do might be to I think we focus on things like these next, maybe. And these, like, I think this is just the right next stuff to do right here. Yeah, okay. I'm going to wrap it up there for today. I'm going to try to keep this up all week. So I'll be back again around the same time I was on today for Thursday and Friday and try to make more progress on this. I think it's going to take a couple weeks just to crank through a first pass of setting this thing up. And I have a couple of other big ideas about what we want to be looking at in the future too. So I'm rolling out for the next few weeks, really hoping to crank out some more of this PE generation stuff because it's going to go pretty far. So look forward to that. Come and hang out if you want. And keep in mind that I'm able to keep working on this if people like you who've got a little spare money are so kind as to go and look at MrForth.com membership and decide if you are able to do a little bit of support or become a member. It is hugely appreciated. I'm counting on folks like you to do that so that I can keep projects like this going. With that, I will see you around the internet. Bye-bye.